Okay, well then we should be live. I think we are 1 minute early, but I don't think that's any kind of problem. So welcome everybody to the last session of the day. This is going to be a really interesting session, hopefully pretty informal. If you have any questions, put them in the live chat. If you would like to join the actual Jitsi meeting, please use the link that I have posted in the live chat. It's there now. And what's going to happen is Tim's going to take us through a way or how to set up your own vector tile server to be able to use in QGIS, which is really cool. And I'm excited about that. So over to you, Tim. Let's get started.
Thank you. And hello, everybody. Can you hear me okay?
Yes.
I'm sorry, I've got a bit of a cough, so apologies in advance if I break out in coughing without being able to reach the mute button in time. Yeah, so let me share my screen here. So my story is I got sick with COVID. That's why I've got a cough still. And I couldn't really do any productive work, but I thought I would just play around with vector tiles a bit while I was sick and try to assimilate some of the information and knowledge that I had into a kind of one place. So what I wanted to do is just kind of show you, let's see if my slide show will work if I do that. Ooh, that's not what I wanted to do. Where's the play button? Does that work at all for you? No, because it's showing on the wrong screen. Hang on a second. Okay, anyway, I'll just show it like this. So I wanted to kind of show you a little bit what you can do with vector tiles in QGIS, what vector tiles are, and how you can host your own, and how you can style them, basically. And maybe try to get other people excited about vector tiles as well, like I am. So I've got a nice, catchy slide for I think I've lost my slide deck. That's going to be very... Okay, that's big relief. Okay. Okay, so we'll do a little dive into the vector tile ecosystem and show you how with QGIS you can get productive use out of vector tiles. And the goal is to be able to produce nice cartographic products like this that you can use in QGIS, but that you can also publish on the web, like in a web mapping application like Leaflet or OpenLayers based application. So a quick overview, we're going to just look a little bit at the history and background of what vector tiles are, how they're structured, how you can use vector tiles in QGIS. Shame on me for leaving out the I. How you can style your tiles, and then how you can host your own if we have time. Hopefully we'll have enough time at the end. And I'm going to do this last bit as a live demo, seat of the pants thing, so hopefully everything will work. If it not, we might do a bit of communal debugging while Tim figures out his technology. All right, so why do we have vector tiles? Actually, vector tiles, if you look on this Wikipedia article, they've been around since 1966, so older than me, just by 3 years. They're basically like these tiling systems are an efficient way to represent data in a hierarchy, such that you're not trying to load your whole data set into the computer's memory at one time. So in 1966, they probably were being pragmatic because they didn't have a lot of memory in their computers, and they came up with a way of like generalizing the data. When you zoomed out, basically, you show a much more generalized version of it, and as you're zooming in, you show details, but just for a small area that you zoomed into. And that way, you don't need to load everything into memory. So there are quite a few tiling systems out there already. Vector tiles is just another one. So there's WMS TMS, the tiled map service, and there is various raster formats. So they do the same thing where they basically organize the data in a pyramid. So they'll have one tile, which is like the world where you zoomed out the most and you just see the whole world in one single tile, and then they split that into 4, and you zoom in one level, you get 4 tiles, and you zoom in another level, you get 4, to the power of 2 every time. So you'll get 16 and then 32 and then 64 and 128. And as you go down, you're getting more and more tiles. And eventually, when you get to like 100 meters on the ground or something like that, your tiles are tiny, but there's billions of them to cover the whole Earth. And in vector tiles, they're organized in that same structure, but each tile contains vector data rather than a picture of whatever it is that the tile represents. And the vector tiles are quite nice in that you can store multiple layers in each tile, and then the cartography is done separately to the storage of the data or the delivery of the data. So if you're working with the map tiles, like raster tiles, you render the cartography into the tiles and you store the tiles on disk, which is great and can look very nice. But if you want to change the color of a road from green to pink or something like that, you need to re-render your whole tile set. With the vector tile system, you only need to change the styling rules for the tiles, but you don't need to regenerate the tiles set. And the time that you need to regenerate the tile set is when the data changes, not when the representation of the cartography of the data changes. So we got this hierarchical structure. They're usually stored in a ZXY or XYZ or YZ. Each vendor tends to have their own structure, but typically they're 3 dimensions. So you've got the zoom level and then an X and a Y coordinate or tile offset that you're working with. And then you can predictably see from that coordinate, okay, I'm at level 5 and I'm getting the 5th tile on the left and what have you. So that's how they're organized on disk. One more thing just about the storing on disk is that there tends to be a few different ways that people store the data on disk. The one is they put it in like something like an Amazon S3 bucket or something like that, where it just goes in some like cloud native storage. And then you have some lightweight service in front of it, which just pulls the tiles out and sends them to the client. Another way is that you'll store them just on a file system with Nginx or some web server in front of it. And there's something to be aware of there is that because you potentially could be generating billions of files, and they tend to be typically quite small files. If you're working with raster tiles, they're more predictably small than vector tiles, but you might run out of like file system file handles on your file system, operating system file handles on your file system. So you've got to maybe do some careful things to prepare your disk in a way that it can cater for lots and lots of small files. And another way that the tiles get stored is in an MB tiles or Mapbox tiles database. Is essentially a SQLite database, and then you basically have one big file on disk, but inside of that database you've got all these little blob entries. Each one has a record which says what its X, Y, Z position is, and then this blob which is just the data that goes with it. And then you'll typically have some software in front of that which goes into the MB tile store and pulls the correct tile out and sends it back to the client. All right. As Amy said, I like to be informal, so please feel free to interrupt at any point if you want to ask questions, and Amy, you can just proxy interrupt if there's anybody in the chat wants to know something. So inside of a vector tile, what do you get? If you use Ogre, and that's another important point to mention, is that vector tiles are fully supported by GDAL OGR, so you can read and write them as you want to with Ogre, or in this case, I'm using Ogre Info to have a look inside of one tile. And if you open it, you can see it says using this MVT driver, so that's Mapbox vector tiles. The format is not specific to Mapbox, but they kind of created a namespace around them because they made them popular, I guess. But you don't need Mapbox at all, and you don't need any Mapbox tooling anymore because there's now MapLibre, which is like an open source JavaScript library for working with Mapbox with vector tiles as well. So You'll see Mapbox name pop up a lot, but you don't need to buy any services or pay anything to them to use MB tiles or vector tiles. So you can see inside of this tile, I've done a little listing of what's inside, and you can see that it's got multiple layers. So that's one of the interesting things about a vector tile, is that you can have multiple layers inside of the same tile. And the layers can be different geometry types. Points, lines, polygons can all be mixed up together into this one tile, and they'll have a name and a number for each of the layers that are inside of there. If you've defined your tile set, usually there would be zero, all of the layers would always be present, but there may be 0 or more features for each layer in a tile. So yeah, you can have different geometry types. The geometries can have attributes as well. So you can have like the name of a road linked to the geometry, or the type of the road, whatever other attributes you want to package into the tile, you can do. But you should be cognizant of the fact that the attributes will be repeated in each tile if they're representing the same feature. So quite often we might just put a code or something in as the attribute, and then look it up from a database if we need a lot of data attached to a tile. And then it's important to emphasize that each tile is clipped to the tile boundary. So for example, if you've got a map of South Africa or a map of whatever your country is, when you zoomed out a long way, you might fit that whole geometry of your country in one tile. As you're zooming in, it's getting chopped up, and there'll be some straight line edges like in the boundaries between the adjacent tiles. And you can then sort of like represent your country by coloring it based on its attribute as one color, and tile boundaries will not be shown. It will look like it's one big polygon. There's actually your polygon's been chopped up into little pieces and then reassembled at render time. So here you can see I've done now gone to get a little bit more detail. So I've done ogre info, the tile number, and then I've given it one of the layers as a parameter. And it tells us a few more things. It tells us the name of the layer, what the geometry type is for that layer, and how many features. So in this case, we're looking at a layer which has got 0 features, but the layer is still listed in the tile as being part of the tile set. Whereas in this case, we're looking at one where you can see the number 1 here. There is 6,055 features. There's this extent which shows the boundary of the tile, and that's basically in the spec they say that all of the tile coordinates should be like relative to inside of the bounding box of the tile in its own coordinate space. So basically, normally you'll see that the bounding box will be up to 4096, and then all of these coordinates will be something up to 4096. Meaning like 4096, 4096 would be, say, the top right of the cell of the tile, and 0,0 would be the bottom left, and then all the geometry is sort of relative to that space. The spec also says that there should be no decimal places in these coordinates, although I see some tile generators do actually put decimal places in there. You can see in this screenshot that I'm looking at this one layer, roads. I can see the number of features, and then I can see the actual features listed out here, and it shows them as well-known text geometries. So well-known text being this sort of like open standard way of representing a geometry. And these are lists of coordinate pairs. So the comma separates a pair of coordinates, and a space separates the two X and Y coordinates for each pair. So inside of the tile, you just basically got a whole bunch of these WKB. They're actually stored in the tile in, I think they're stored in the they're actually stored in this protobuf format, which is something else I forgot to mention. So the actual storage format is something called a protobuffer, which is something Google invented. And it's a binary format which can package a lot of information into a small, like package it down to a small space. And then when you unpack it, like I've done here, it's unpacking it into a well-known text format. So that protobuf format, you might see PBFs mentioned, like for example over here, I've listed the PBF. So that's the storage format of one tile, and then the tile system determines the layout of how the tiles are arranged in that pyramid. You can have vector tiles also as JSON and other formats as well. But the Mapbox vector tiles we're working with is in this protobuf format. And I should say protobuf is like it's a format, but it's not a fixed format. So you can have different companies or projects can use protobuf and store things in different ways. So it's not a predictable organization of the data inside of there. All right, so that's just a bit of background about what the vector tiles are. I forget which version, but maybe 2 years, 3 years back, Martin Dubiash from Lutra Consulting introduced vector tile support natively in QGIS. So if you go and look in QGIS, you'll see in your browser menu, you'll see this vector tiles section. Yours probably will have only just one entry in it, the map tile countries like this. I've actually, let me just go and remove this style quickly here. So if you open it, yours will look more like this. So you'll get just some generic looking thing. And this was kindly donated by the Map Tiler project, who basically allowed QGIS to put this tile set in QGIS by default. So everybody who opens QGIS in a recent version will have this starting set of tiles here. And there's no cartography for that. So it will might show purple or green or pink or any color for you when you add it in. But it gives you like a starting set of data that you can play with. And it only tiles up to, I think, level 14. Just double check here. I think it does up to level 14. So if you're trying to zoom into your house, you probably won't see your house. It's just got the country boundaries, basically. So yeah, out the box in QGIS, you can just drag and drop these vector tile layers into QGIS, and QGIS sort of reassembles them to look like a seamless data set. But if I zoom in, you'll see that they're coming in blocks. Like if I can get it to draw slow enough, hopefully you can see as the screen's like updating, it's pulling in these little boxes at a time. It's not all coming in as one layer at a time. So that's QGIS actually going off and fetching the tiles. And if you press F12 to get the debugger open here, you can actually see those tile requests going out. You can see it going off to maptiler.com. It passes this API key that they've set up for us so that we can use this. And you can actually even go and open one of those tiles in your browser. It will download it, so that 13.pbf, and then you can, if you want to be a bit nerdy, you can go and inspect it by doing that OGR info like I was doing now. So you just got it pointed to the download that you fetched, and then it will tell you, okay, that layer contains this administrative boundary, or that tile contains one layer called administrative boundaries. And if you wanted to look inside of the data that came in there, you could look in it like administrative. Okay, so I just have to spell it right. And there you can see all the attributes that were included in that. It's basically name has been spelled in a whole bunch of different languages. And then it's got the actual geometry for that tile. And it tells you what the continent is. So you can use the information that you see linked to this tile. There's actually multiple features in this tile as well to go and style it in QGIS. So if you go to layer styling here, you'll see that QGIS sets up some default rules. The styling is a little bit different to what you might be used to in QGIS, in that you kind of need to think of it like a rule-based renderer, and you need to kind of really set up rules as you go, because I can come here and just change any anything, but you can see that the tile boundaries are getting drawn now. So you've got to choose your style in a way that it kind of works well with tile data, and you can't easily set up rules like you can with a rule-based renderer. So if I was using a rule-based renderer, I'd say create a new rule, and then you'd have the expression editor, and you could go and write your expression, and QGIS would help you write the expression. But in QGIS, in vector tiles, you need to do a little bit of this poking around in the data. So you need to look at the attributes either in this way or just in QGIS using the identify tool. Identify tool. So you can go click on a tile and you get similar kind of thing to what I was listing in the shell there, and you can look and see, okay, I've got, for example, a level attribute or a continent. Let's say I want to color all the African continent with red. Then I would go back to my layer styling now, and I'd make a filter here to say and continent equals Africa, something like that. And I think I did something wrong there. Let me just see. It's capital A. Yeah. Let's just also do here. Okay. So I had to specify the layer, which I found out by doing the identify and poking around to see which layers are present in there. And then I had to write my own rule here. And I didn't get a lot of help doing it. I had to kind of know that I can use an AND statement and how to structure the subset query. But I was able to then pull out like all the tiles which are part of Africa. And then I can style Africa now according to this rule. So I can go and come and double click over here, and I can say, okay, let's make Africa this gray color, for example. And then I might do another rule, which I can kind of say over here, let's make a full rule. And this rule, I might give it its own logic. So let's go and make it also administrative. And in this case, I'm going to say and not and continent. It will let me do this. So you might have to do some trial and error to get the right syntax. I seem to have got an extra one there as well. Let's get rid of that. Okay, there we go. So I think if I turn this one off, you'll see Africa's been excluded in the pink one, but it's included in the gray one. And so I can sort of come up with a bunch of rules here. Now I could come to this one and give it its own styling and what have you, and build the set of vector style rules. And what's cool about it is that I can use all the QGIS styling system, but what's not so cool is that it's a little bit more technical to come up with these filters and rules, and kind of a little bit manual. You don't have all the helpers that like will automatically create classes for you and what have you. But I can then take this online vector tile data source. It can be any data source. It could be the one that ships with QGIS, or you can, if you've got a Mapbox account or a MapTiler account, as we'll see just now, if you're hosting your own tiles, you can link them up to QGIS and then set up your style rules for them.
Tim, we just have a quick chat query. Someone called, I think it's Groene B.
Groene B, yeah, he's from the Dutch.
My Dutch is rusty, so let's go with Groene. I have no default vector tile connection using QGIS 3.26.2 from the Windows MSI download option. So does Windows make a difference?
No, I thought it came shipping with by default, but maybe I'm wrong then. I'll have to check on that for him, or we'll go and look in the source code in a minute and see. But I almost thought we shipped this by default. Yeah, I'll have to come back to
Well, hang on for a while, Gruner, and then maybe we'll have a look at it. I see I've got a comment.
Ethan says he
from
also doesn't have
Ethan.
it. Yeah.
Interesting.
Don't worry, we'll hook you up with show you how to get your own tiles going. So don't feel left out if you if you don't have that one in there. But yeah, I can take a quick little detour. Let's go and do a little detour quickly and go and see if it's.
Alexandra also says that he doesn't have it in Linux. Raymond says switch to Linux.
Oh no, late, Raymond. Okay, I could have sworn that it was shipping with, but I can see there's some stuff in the code here about having test connections to it. I'll just do one more thing. Okay, maybe it doesn't ship with default. That's pity. I thought we were doing that. Never mind. I'll show you how to find your own, get your own sources. I hope I haven't shared now an API key on my broadcast, which isn't supposed to be shared, but anyway, I think it should be fine. Okay, but once you set up your vector tiles, you'll see them here. We'll show you in a minute how to get more. In fact, if you go to Open Map Tiles, maybe it's a good place to jump straight into right now. So we can go here to open. Actually, I have it open here already. Open source map tiles here. Oh, that's the styles, but I think they also have some. Let's have a look. That's all the styles. I think if you get a free account, you can also just connect to the map tiler. They've got some free data sets as well. I think come and have a look at maptiler.com and poke around there. There surely will be other ones online. But anyway, like I said, we're going to show you how to host your own too if you want to, so you won't feel left out. Okay, so let me go back to my flow here. So I've shown you there that you can drag and drop the map tiles in. Once you do that, this is again, you'll see it's a special type of layer with this little grid icon next to it. The styling is just default, as I've shown, and you can see there all the attributes that I showed you in a second ago. And then if you're working with something a little bit more complex, you can actually automatically get all the styles, which I'll show you how to do in a minute as well. So when you set up your connection in QGIS for a tile layer, if you go to the edit connection, you'll see that there's a box here for the style URL. So you can actually create your own styles using an online Mapbox compatible style editor. I'm going to show you the one called Maputnik editor. And then you can put the styles online anywhere you like. I just put them in a GIST or GIST or whatever you call it, but it could be on your website or anywhere. And then you can have QGIS go and grab that file whenever you add the layer, and it will, as best as it can, take all the style rules from that Mapbox style and turn them into QGIS style rules. So I'll show you that workflow in a minute. All right, so basically there's two options. The one is what I've shown you already, which is you can go in QGIS and you can create the styles. The problem with that option is that it's you can't convert the QGIS styles into Mapbox styles. So if you're wanting to host that QGIS project on the web, you need to host it using QGIS server so that it can like interpret the style rules for you. But the other way to do it is to use a web-based vector tile style editor. That's a mouthful to say. And that with that you can create this Mapbox compatible style.json file, and QGIS can read that and turn it into QGIS rules. But also web clients like a Leaflet or OpenLayers client can also read the, or MapLibra, sorry, I should say, can read that JSON document and then use your styles like in a web browser. Okay, so I am going to show you an example of doing that first with the MapTiler style. I've just shown you here, this is the QGIS one, which I already just did a little demo of, so you can make some rules like this and then change the style of the layer. But I'm going to show you how we can actually go and use Maputnik editor to do that. Now, to do that, we need to run this Maputnik editor program, and I'm going to share a link at the end with the Docker, with the GitHub repository with a whole Docker project, which has everything that I'm showing you. You can use it and play with it yourself. So I'm just going to show you that at the moment I've got this Maputnik editor running over here, and it's running on my local machine on this port number 888. So and the way that I started it was just simply saying docker compose up -d Maputnik editor like this. I'm going to say it's already running, but if you're in an organization and you're not a Docker guru or anything, you can just ask your friendly system administrator to run it on a server. It's all web-based, so you can put it on any server in your organization and then just have a shared instance that you can all connect to. When you run that, you'll get something that looks like this, and I'm just going to open like an empty style here. So they actually start you off with one of their Mapbox styles. So this is showing Mapbox tiles here. You can see the kind of cartography they can achieve just using this. These are all the style rules here, but we want to make our own ones, and we want to use those MapTiler countries to do it. So I'm going to go just back to QGIS. Again, apologies, I thought it was all part of the default setup, but we'll find a link for you in a minute. So I'm going to use that link to that MapTiler layer that I've got. I'm going to go to Maputnik here. I'm going to say create a new data source. And MapTiler countries. I'll just call it MapTiler countries. And then you'll see that they've got a whole bunch of different tile formats here. So remember I was saying that you can get like JSON-based vector tiles or raster-based tiles, whatever you. We want to use this vector XYZ URLs. Okay, and then we're going to give it the URL from QGIS or from whoever has provided you with access to the tiles. And you can set some zoom range limits here. Like I think in the tiles that they provide is only up to 14. And you can just give it a friendly name, and then you say add source. And then you'll see that it's listed in, I forgot to give it a friendly name, but anyway, it's this tile JSON URL here. Let's go back and just, oh, there it is over there, MapTiler countries. We can get rid of these other ones here. Okay, so I've got this source created, and then I'm going to just start a new empty style here. So there's nothing on my board at all here. And I can remember that the structure of the data has really got just one layer called administrative, and there were some things about countries and continents and so on that I could use to start it. So I'm going to go here and say add a layer. I'm just going to call this admin. And then they've got different layer types that you can have. A background layer could be, let's put this one in here. Could be just a solid color that you put in the background of your map. So you can go here and choose a nice pleasing blue color or something like this. And that can be just sitting in the background of your map. And then I can say, and I want to add another layer. Those admin boundaries are now. In this time, it will be a fill. But you can also do lines, symbols, or if you want to do like labels and things like that. Raster could be like some tile-based raster layer, circles for points, basically. And then they've got some other cool stuff for doing heat maps and things as well, which I've played around with too. You can have some fun with that. Not all of these things will translate into QGIS styles, though, later. So if you stick with the full line and circle or point basically, and the symbols, you'll be probably okay with QGIS. If you're trying to use these full extrusion, hill shade, and heat map, QGIS won't know how to render it. I don't think you can try it, but I don't know how well it's going to work. And then here you choose the source, and I've done something to not have a source there. Let me just go and fix that. Data sources. I did manage to lose my source. Let me just add it in again here. Okay, so I've got my map tile of countries. Let's try that again. Okay, so now I can see map tile of countries. I'm just going to call this admin. And the name of the layer was administrative. And you can get that name from in QGIS here. When we clicked on the identify results, it lists them grouped by their layer types. Or we can get it from the shell by running that ogre command that I showed earlier. Okay, so if I add the layer there, that's the same vector tiles now that's being published by MapTiler. And it's now showing up in QGIS, and it's given it a default black style, and it's got my background behind it. If I didn't have the background, it would actually just be, okay, this gray background, but could look like just sometimes when you open it, you might be zoomed right in and it just looks all black. Let's make sure to zoom out first time. All right, and then I could play around in here, making rules just like I was doing in QGIS. So I can say, for example, let me change the color of the border. I can go here like this. I can change the color of the fill. I can make rules. For example, if I want to do the same kind of thing I did just now, I could clone this one, make this one, call this one Africa, for example. And then I could make a rule here to say every filter must match, add a filter, and the continent equals to Africa would be my rule. And then I could change the color for this like this. Let me just see. Continent equals Africa. Let's go and look. I have to maybe put this one down below that one there. There we go. Okay. It works in reverse to QGIS for the Z order, which just might fox you in the beginning. So the thing at the bottom of the list here shows at the top of the map, whereas QGIS does the opposite way around. This one here still has Africa included in it. So just to copy what I did in QGIS, I could go here and say, basically I can say no filter matches. And I can say continent equals Africa. That means like show me every polygon where the continent is not part of Africa. And then you can see Africa's disappeared, and I've got Africa in this one over here. Right, and so you can basically, there's a lot of different options here. It actually gives you like a JSON document that you can copy and paste, which is quite nice as well. You can make up long list of complex rules looking at all the different data layers that you've got and setting zoom levels for them. So over here you can say like only show Africa when you zoom into a certain point, and you can set filters, and depending on what other things you've got going on in your data, you can create more and more complex rules. So you can see that that's turning on and off as I zoom in and out. Okay, so now I've made a style. What I can do is export this style. I can just download it as an empty style file like this. And then I can just go and open it in whatever text editor you've got on your system. Now you could put this anywhere on a website that's accessible by QGIS. It could be just on a local web server on your own machine, or like I said, what I tend to do is I just use a gist in QGIS. So I'm just going to modify this one over here. I'm just going to paste the contents of what I just created into this gist here. And then I'm going to get the raw URL for this. It's basically just the simple JSON. And you can see that the rules that I made are being listed here. So there's my filter continent equals Africa, and that one was none, and this one is all continent equals Africa, and there's the colors and all the other things I specified. So if I take this URL here and I go to my QGIS, let's go back to my browser. And now I can, in the style URL, I can put that URL. And when I add that layer into QGIS now, it's going to go online to that website or the gist and fetch the styles and apply them and generate the rules for the styles, just like I would have done manually. But I didn't have to now write those rules out by hand here. And it's even brought the zoom levels and things. So if I zoom in here, Africa will appear and disappear based on my zoom level. You can come and tweak them afterwards if you want to here. But you got the luxury of using a nice user-friendly editor to... okay, there's a little quirk. I'll just put that to 0. Okay, and then I will keep it on. So that's Maputnik editor, creating a JSON file, and you store that JSON file online somewhere, and then you can create an entry in your browser with the style file and the URL to the tile server. And whenever you add it to your map, you're going to get that style automatically added. If you want to as well, you can save this as a QGIS layer definition file, and then pass it to other people in your organization or wherever you're working, or whoever you want to share it with, and they can then take that and then just open it, and we'll just open the layers from the remote source, have the style and everything all just in one simple file. All right, so that's the kind of key process of styling layers that have been hosted by somebody else. But the last thing I'll try to show you, and that's where we're going to go by the seat of my pants now, hopefully everything will work, is where you can actually host your own tile server based on Openstreetmap or any other service you want to provide. So I will show you that. Maybe I'll show you just a simple case first where I'll just host one based on my own data that I'm not even going to worry with Openstreetmap. So I've got Postgres running. I'm going to make a connection to it. I've got Postgres running in a Docker container here. So you can see it over here. It's available on the normal port here. And I've got a little configuration file here with the username and password to use. So I'm just going to copy those, make a new Postgres connection in QGIS. And I'm going to put my local host here. And then I'll use the connection details of some user and connection. Okay, it's working. Tick some boxes there. Okay, so I've made a new Postgres connection, and it's over here, and it's empty at the moment. It's got no data in it. So I can take any layer. Let's go and just make a fresh project here. and we'll use our famous Easter egg. I know Raymond's waiting for me to use the Easter egg at least once in my demo. So I can type world there, and I can get basically this built-in world map that ships with QGIS. I'm just going to rename it to world. And then I can drag and drop it into, just before I do that, I always like to just highlight the scheme I want to drop into. There we go. So I'll drag and drop it into my database. So now if I look inside the database, I've got this world layer. I can take it out of here, right? And then I can run this software called Tegeler, and there's a whole bunch of different open source software applications that let you do the same thing that Tegeler does with some variations. So the ones that I've looked at are PG Tile Serve, not to be confused with PG Feature Serve. PG Tile Serve lets you connect straight to a Postgres database and serve any layer, any table you find there as vector tiles. And there's another one called Tippecanoe, which is written by Mapbox as well. I think it's open source and it's freely available. It's got some pretty nice features, but I like Tegeler because it's really simple. It's just a single binary to run, so it's easy to set up and deploy. And it's got this seeding function, which will allow you to tell it to go and actually pre-render all the tiles into the vector tile cache for you. Tippecanoe can also do that, but there were some other little gotchas that made us prefer Tegeler when we were searching around the different options. So we can run some software called Tegeler, and to use Tegeler, you need to have a configuration file. This is where it gets a little bit nerdy, but not too badly so. But you basically need to, and I've got an example in the Git repo, but you basically need to set up a configuration file that looks a little bit like this. I'm just going to delete everything that's not relevant here just to make it more simple to understand. Let me just see if I did everything right here. Just want to avoid introducing some other complications here with this MVT business here. So I've created basically a connection to the database. You can use these environmental variables which Docker will pass into your file. So all the usernames and passwords and everything just gets passed over from that little environment file that I was editing. You basically define a Postgres connection. You can also use GeoPackage as the data store if you want to. There's not too many other formats. It's pretty much focused around using Postgres as your data store. So you define this provider, which we call DB, and then you define layers, which is the connection details in the database for a particular layer. So in this case, I'm publishing public.world, which was what I named this layer when I dropped it in here. And it's looking for an FID for the feature ID and the geom field. So I've just specified these two things over here as the ID and the geometry field. And then you add that layer to a map. So here I've made a map called world. And I've defined the layers that go into the map to be one which references it by DB here for the provider name and the layer name world, so db.world. And you can say what zoom levels it should be visible at. So I can make this to just like the other one we saw just now. I can make it to 14, for example. So that's like probably the most simple configuration file you could do for Tegeler. I've set it up to use table mode, so you basically just give it a table name, but you can also pass it a SQL query to say, okay, pull out just a certain set of the features and display those. So let's try and start Tegeler. See if we can get it to run. Okay, and then I always like to just confirm that it's running here. So it is running. And I also like to just look at the logs just to make sure if there's any issues with your with your tabular configuration, it will tell you here. So I think those are old issues. So I think we're good to go now. So that's running on port 1990, and I can go in my browser, just open that. Tabular provides its own little preview of the layers that are published as well. So there's the world map that I created. You might have to zoom in and out. Just turn it off. I can see the zoom level I'm at over here. There we go. So there's my layers being drawn in. So at the moment, it's fetching them out of the database and saving them to disk as I do stuff. So it's quite slow. I haven't built any spatial indexes or any other cool stuff to make it faster. But what it's doing then is writing each of these tiles as it renders them into this folder here. So let's go and look. So you can see that there's the level 0 tile. Let's see. Should be writing the files into there somewhere. Okay, so now it's managed to render like the whole country, and if I zoom in a bit like this, it's going to do some more thinking perhaps, and writing more tiles and so on. So I've got basically, I've set up my own tile service now, just on a Postgres database layer. And then I can go back to, I can just copy this URL. It's probably the easiest. I need to just include the word world in there, I think, as well. What I tend to do is just, let me see if I can do it like this. I tend to just go and inspect this and look at one of the network requests that get made. So if I zoom in like this, and then you'll see that it shows you that it's looking at maps.world, and then it's got X or Z, X, and Y. So what we're going to do is we're going to take that over to our Putnik editor. There we go. And we're going to set up a new data source. So I'll just start a new project, in the empty style here. I'll go to my data sources. I'm going to create a new one called Tim or something exciting like that. And we'll use that vector XYZ URLs. Now it's got most of what I need there, but I just want to change this part in the front here to use that. And our arrangement, and this is just something you got to kind of learn from using different tools, is ours is in Z, X, and Y. So Z, the first level directory is how zoomed in you are, and then the next one is where you are on the latitude, on the longitude, and then the last one is where you are on the latitude. So if we add that source and we just confirm that it's there, and then we can go do the same workflow we did before, but now we're working with our own data. So let's make this one a background. Same like we did before. And we can set this to some pleasing color. And then we can add a layer here. And this time we're going to do countries. Full layer, we take it from the Tim data source. And the country name is called world. Let's see if we're going to get something shown. I'm just going to watch my logs. Always if I'm doing things, I just like to watch the logs to see if there's any errors or anything. Let me just set the outline color here to black. Just want to go check the data source again, make sure I didn't make a mistake. Z, X, Y. I'm just going to look in my QGIS here to one I made before. Okay. There we go. So now it's drawing my own data from my own database. Again, it's a bit slow, but it's going to be caching it so it should speed up in subsequent draws. And I can style this as I want to. So we can change the color of anything, change outlines, set rules. I can also go in here and use the inspect tool to go and actually, oh, that's quite a nice color, accidentally. Maybe that's because I'm doing inspect. I don't know why it's showing the color. I can see all the attributes from the database here. So for example, if I want to make a rule based on name, I could go in here and say, let's make a new rule. So name equals Angola. Okay, and then switch it back to this one. So for the Angola one, let me just see here. If I want to test why it's not working, I can just turn that off and on again. It's capital letters, so it's probably case sensitive here. Okay, so there I've drawn Angola just in red, and then I can go here and make another copy of it. I'll just call this countries all, and can move this, we'll change this to not equals to Angola, and change this to a different color. So you can have fun and go and come up with your own style rules with your own data sitting in your own database. And then the flow is the same. I can go and export this, download the style. Oopsie. Copy this to my clipboard. I'm going to go back to my gist over here. I can find it again. I can edit this. This is just a sneaky way of getting it online. You don't have to use this way, but update the guest again, go to the raw version of that. And then in my QGIS session, I can make a connection to that same layer. So let me just do a new one like this. I'm going to put that style link in there. I can tell it what zoom level to go up to, and then I need to use the same URL format that I used in the styling thingy over here. All right, so I've made a new tiled entry in QGIS. This one over here, and if I drop it in there, then it's styled according to what I did in the Mapbooklink editor, and it's all coming in as vector tiles. And once it's cached, it's not very efficient now because it's still caching stuff, but normally you'd run this tabular seed tool to go and pre-cache everything. And it will be super fast, super performant way of sharing the data with the cartography to all your users. And we've got 1 minute left in the session, so I won't try to show you now, but I'll just tell you that you can go to MapLibre. It's a great project. They've basically continued the open source version.
Live streaming is on.
We're back. You didn't miss anything, but basically, if you come to MapLibre, you can find in here some examples. I think they had like a quick start. Yeah, there we go. A quick start here. And you can just basically replace your style URL here and your data source for your, where is it? Somewhere along here, you'll also specify that data source. And then basically you can use those same styles to make a web map like they've done over here. So there's more to look at if you go to the repo. I'll just put the link up on the screen at the end here. So I've got a slide deck that will go in the repo as well. But if you go to this repo, I've shared all the workflows of everything I've done there, and including there's a complete tooling to make a mirror of the whole planet from Openstreetmap in your own local Postgres database, and some starter styles for actually drawing that planet as a nice MapLibre style. And I'd love to have people who are good at cartography contribute to that as well. That would be great. And that's it.
Awesome. Thank you, Tim. That was fantastic. We have kind of an off-topic question, but maybe you can answer it. From Samurai Jack. Sorry, this might be off-topic. I'm working on Windows and I'm trying to work with PG routing. Can anyone provide me with some good beginner resources?
Not that I know offhand. I would just look in the old Google and look for things.
The University of Google.
Yeah, not sure where a good place to start is.
And I see that the next bit of advice for Groen on the chat is all you need is a connection to the MapTiler Vector Tiles API to get that into QGIS, because I know we didn't have it. So that's all.
Yeah, I think you can just go here and create a free account, and then they give you some like link. I won't try to figure out my login and all that now, but yeah, so it should be pretty straightforward. MapTiler guys are nice guys. They're like open source friendly guys, and be nice to support their work. But there are other commercial tile providers online as well, or you can self-host like I was showing you.
Awesome. There aren't any other questions in the live chat. I don't know, Ethan or Victoria, who are in the room. Do you have any questions?
Yeah. So for this, for the tiles, particularly when you're styling, can you, I don't know how to do it, but configure some of, like, we have the stylings for OSM mirror and sort of use them for the tiles, although just so you don't have to start from scratch, you can actually
So, and I forgot to give you guys a lot of credit because I based this repository that I'm showing you here. I based on a bunch of work that was also done by Amy and Vicky and CLBware from our team back at Cartoza. So we have another project called OSGS, and in that project we wrote a bunch of like transform rules to take Openstreetmap data and put it into your Postgres database. So I recycled all that work that you guys did, and those rules are in this OSM conf mapping. This is all exactly what you've built, Vicky. So that's the first step. Is you can run in this Docker project of mine. You can run this in Possum process, and it will load all the OpenStreetMap data into the database using this mapping scheme. It's the same one you're familiar with. And the second step, your question about the rules, is that in the repository, I've shipped two project files here with quite more comprehensive rules than the simple example I gave here. And the idea is that we extend that set of styles and maybe create more different styles. Like, I know Amy wants to make a black and white one or a monochrome one or something like that. You can just drop them in here, and then you can, if you run the full planet and you load up the styles, it will just pull in all that styling for you, and you can just use it out the box. Does that answer your question, Vicky?
Yeah. Thanks.
Awesome. Anything else? I know we're 5 minutes over. Thank you to the viewers.
I'll stop talking. Just apologies for not using my QGIS mug today. I'm going unbranded.
All right, brilliant stuff. Thank you so much, Tim. This is fantastic. I'm definitely going to go have a poke around the repo. Keen to make that monochrome map. So let's see. Hopefully I get some time in the next coming weeks. And just thank you, everybody, for being at Open Day today. This is, of course, the last session, and we will be having the next Open Day next month, as per usual. So thanks, everyone, for joining for the journey, and all the best.
Arrivederci. Have a nice weekend.
Bye, everyone.
Cheers.
Cheers.
Bye-bye.
All righty.